In my previous video, I introduced you to the concept of the unit step function and how to take the Laplace transforms of the unit step function. So here in this video, we are going to use the results that I derived from my previous videos into solving the Laplace transforms of unit step functions. Right, so let me refresh your memory with the definition of the unit step function u of t minus a. This is equal to so this one we have 0 if t is less than a. So as far as t is less than a, the value of the unit step function is 0, and then it switches to 1 if t is greater than or equal to a. Right, so this is what we have for the definition of the unit step function, and this one is what we call the Heaviside function. So the Heaviside function. So how do you define that? So u of t minus a multiplied by f of t minus a. This is equal to what? So this is equal to 0 if t is less than a. Right? Because if it is 0, this unit step function is going to be 0, which will multiply by this, which will be 0, right? But it will switch to f of t minus a if t is greater than or equal to a. So if t is greater than or equal to a, this will be 1, which will be left with f of t minus a. That is what we have. So now we're going to use these definitions and the results from my previous video to solve the Laplace transforms of 6 different unit step functions. So let's start with the first one. Question 1, we have to find a Laplace transform of this one. F of t is equal to this. So 0 if t is greater than or equal to 0 but less than 3. And then 5 if t is greater than or equal to 3. How do you take the Laplace transform of this? Let me draw it for you here to see. So a graphical illustration of what we have here. So this one is going to be equal to, so the value is 0 for t in between 0 and 3, right? So let me use the yellow pen. So in between 0 and 3, like this, so let's say 3 is here. So in between 0 and 3, the function is 0, right? So that means this one is 0 and this one is 3, right? So this one is our time axis, right? So but then it switches to 5. It switches to 5, so that is 5 here. It switches to 5 if t is greater than or equal to 3. So that is here. So at 3, it switches to 5. So this one is somehow like filled, and then it continues like this until infinity. So this is not a continuous function. How do you take the Laplace transform of something like this? So we can use the definition of the unit step function to write this one to look like this. So that is equal to what? So this f of t can also be written as this. This one is going to be 5 times the unit step function of t minus 3, right? So this is what we have. So this one can also be written as this. And now we can take the Laplace transform of this one. All right, so we have the Laplace transform of f of t. That's the first question. This is equal to the Laplace transform of 5 times u of t minus 3, like this. So this one is going to be 5, the Laplace transform of u t minus 3. Cool, so now if we go to our table, we are going to use this one a lot. So our table is that the Laplace transform of u of t minus a is going to be e to the negative as over s. So a in this case is s3, right? So this one is going to be 5 times e to the negative as. A in this case is 3, so 3 times s all over s. And this one is equal to 5e to the negative 3s all over 3. All right, cool. So this one is the answer to our first question. Very easy. So you just have to write the function f of t like this. All right, so now let's go to the second one. Why not? So the second one, question 2, we are asked to find the Laplace transform of this function. So f of t is going to be equal to 2 for the values of t in between 1 and 4. All right, and then 0 otherwise. 0 otherwise. So let's draw this one, right? So we are going to draw this one. So drawing this, let me draw the axis, and this one is going to be our time axis. So the value is going to be 2, right? So we are going to have 2 as the value of this function, and that's the value of 2 is in between. The values of t is going to be in between 1 and 4. So let's say this one is 1 and this one is 4. So 4 and then 1. So we have the values of t. So this one is going to be 1 and 1 is going to be filled, and then this one continues until 4, but 4 is not inclusive. But then it is 0 otherwise. That means every other value of t is 0. So that means this one is going to be 0 like this. Going to be 0 for every other value of t, and this one is going to be 0 up until infinity. This one is going to be 0. This one is filled, and it's going to be 0 for all the values of t left. So this is the graphical illustration of this one. So now how do you write it in terms of the unit step function? So we have f of t. This one is equal to, this one is 2 times what exactly? This one is 2 times the unit step function of t minus 1 minus the unit step function of t minus 4, like this. That is from this one, f of t. That this one can also be written as this. All right, cool. So now after this, what do we have? This one is now easy. We can take the Laplace transform of f of t on both sides, and this one is going to be 2 times the Laplace transform of this u t minus 1 minus u t minus 4. So we can split it into 2. So the Laplace transform of this function f of t, this one is going to be 2 times the Laplace transform, 2 times the Laplace transform of u t minus 1 minus 2 times the Laplace transform of u t minus 4. The same thing, right? So the same thing, we go back to our table. Laplace transform of u of t minus a is going to be e to the negative as over s. So e to the negative as over s. So this one is going to be 2. So a in this case is 1. So this one is going to be e to the negative 1s, which is s all over s, minus 2. This is e to the negative as. A in this case is 4. So that's going to be negative 4s all over s. So this is the Laplace transform of the function f of t. So the Laplace transform of our second function is going to be, you can factorize something out, that is 2 over s out, and that is going to be left with e to the negative s minus e to the negative 4s, like this. And this one is the answer to our second unit step function. Cool stuff. So now let's go to the third one. So the third one, let me do it in white pen, why not? So the third one, we have this function f of t is equal to f of t is equal to 0 for t less than 2, but it switches to this function t minus 2 all squared, and this one t is greater than or equal to 2. So with this one, let me plot it for you to see. Let me plot it. So we have this one, our time axis again, and now for t less than 2, so for t less than 2, this is what we have. So when t is less than 2, for all these ones less than 2, so let's say this one is 2. For t less than 2, the function is going to be 0. That is what we have. But at t greater than or equal to 2, we have the function t minus 2 all squared. So the function f of t to be equal to t minus 2 all squared at 2. So when you plug in 2, that is f of 2, right? So f of 2 here is going to be equal to what really? That is going to be 2 minus 2, which is 0 squared, which is 0. So at 2, this function is going to start at 0, that is at this particular point. But what about when t is equal to 3? You are going to have f of 3, that is going to be 3 minus 2, 1 squared is 1. So that is going to be 1. So at t is equal to 3, you have 1, like this. At t is equals to 4, that is going to be 2 squared. So f of 4 is going to be 4 minus 2, which is 2 squared, which is 4. This is going to be 4, like this. So this function is going to behave like this after 2, like this, continuous until infinity. So this one is the function that we are asked to find the Laplace transform of. So this is not a continuous function because it stops here and then it continues for the function t minus 2 squared. So now how do you write this one in terms of the Laplace transform? So writing this one in terms of the Laplace transform, we are going to, in terms of the unit step function, I beg your pardon. So this one, in terms of the unit step function, f of t is going to be equal to, it is 0 for t less than 2, but when t is greater than or equal to 2, the function is t minus 2 all squared, and this is multiplied by the unit step function of t minus 2. So we are going to take the Laplace transform of this. This one is the same as this. Alright, so now let's take the Laplace transform. So the Laplace transform of this function f of t, this is equal to the Laplace transform, the Laplace transform of u t minus 2 multiplied by t minus 2 all squared, like this. Cool. So now we are going to use the second one, right? The second one here, the Laplace transform of u of t minus a times f of t minus a is equal to e to the negative as times f of s, right? So let me write it here. So the Laplace transform of u t minus a times f of t minus a, this one is equal to e to the negative sa times the Laplace transform of the unshifted function. So the Laplace transform of our function is equal to, so we have this, so our a here in this case is 2, right? So comparing to this, a is 2, so that is e to the negative as. So a is 2 times s times f of s. F of s is the Laplace transform of the unshifted function. The shifted function is t minus 2 squared. The unshifted function is going to be t squared. So the Laplace transform of t squared is going to be 2 factorial all over s raised to the power 2 plus 1. And this one is equal to 2 factorial is 2, which is 2e to the negative 2s all over s raised to the power 3. Yeah, so the Laplace transform of f of t, that's our third function, is 2e to the negative 2s all over s raised to the power 3. Put that in a box. Alright, cool. So now let's go to the fourth one. So the fourth one, which I will do in green, so the fourth one is going to be this. We have the function f of t to be equal to this function t, so it is equal to t for values of t in between 0 and 1, values of t in between 0 and 1, like this, and it is equal to 3 for t greater than or equal to 1. Cool. This one, you can draw this one again, so let me draw this one for you to see. So we have this is our axis t, right? So it is equal to t for values between values of t in between 0 and 1. So values of t in between 0 and 1, so in between 0 and 1, this one is equal to t. The function f of t is equal to t. That is something like this. So when t is 0, f of t is going to be 0, and when t is 1, f of t is going to be 1. So it's going to be something like this. So this is for the first part. This one is for the first part, right? So that is this one. But then after 1, that is at 1, then the function jumps to 3. So this one is going to be 1 as well, right? But at 1, at t is equals to 1, the function is going to jump to 3. So let's say this one is equals to 3. This function jumps to 3 at t is equals to 1, like this. Right, so when we have this, so at t is equals to 1, it jumps to 3 and then it stays there until infinity, like this. So this one is going to be the function. This is the graphical illustration of what we have here. But now let's write it in terms of the unit step function. This one is going to be t multiplying what? This one is going to be t multiplying. This one is going to be the unit step function of t minus 0, right? Minus the unit step function of t minus 1. That is what we have here. Right, and now plus we are going to add something, that is this one. This one is going to be 3 times the unit step function of t minus 1. Yeah, so this is what we have. So now after this, we can now solve this one quite nicely. So now let's try to simplify this one further. This one is going to be, so let's distribute in with the t. So we are going to have t multiplied by u of t minus 0 minus t multiplied by u of t minus 1 plus 3 u of t minus 1. Cool. So f of t here is equals to what? F of t here is going to be equal to, here let me shift this variables t, right? So I'm going to have t minus 1, but I can't just subtract 1, I have to add 1, something like this. I'm sorry, this one is going to be minus 0. So t minus 0, which doesn't change anything. Then I'm going to multiply this one by u of t minus 0, like this. Right, and this one I am going to subtract 1 and add 1. This one is going to be t minus 1 and then plus 1, like this. And this one is multiplied by u of t minus 1. Right, plus 3 u of t minus 1. Alright, so f of t is equal to what really? So f of t is going to be, the first one is going to be u of t minus 0 multiplied by t minus 0. Correct. And now let me split this one. So this one is going to be minus this one multiplied by the first two. That is going to be u t minus 1 multiplied by t minus 1. Right. And then minus u of t minus 1. That is this one multiplied by the 1. Right. And now plus 3 multiplied by u t minus 1. Okay, cool. So now we can put them together. We can put the last two together. That is going to be u t minus 0 and then t minus 0 minus u t minus 1 and then t minus 1. And this one u t minus 1 and then 3 ut minus 1. When you combine them, that is going to be 2 ut minus 1, like this. So now after doing this, we can now take the Laplace transform, right? So we can now take the Laplace transform of this and the Laplace transform of that. So now let me refresh your memory with what we have already. All right, so when we have the Laplace transform of u of t minus a times f of t minus a, this one is equal to e to the negative as times the Laplace transform of the unshifted function. And this one, the Laplace transform of u of t minus a alone, this one is going to be e to the negative as all over s. All right, cool. So now let's solve this. So this is just by recalling. So the Laplace transform of f of t, this is equal to, now this one, our a in this case is 0, right? So that is going to use this one. So that is e to the negative 0 times s. That is going to be 0, right? So s times 0. And now we are going to multiply by the Laplace transform of the unshifted function. The shifted function is t minus 0 and the unshifted function is going to be t. So the Laplace transform of t is going to be 1 factorial over s raised to the power 1 plus 1. Cool. Minus this one, the same thing. That is going to be e to the negative s times 1, because here a in this case is going to be 1, right? So s times 1 is s, and now multiply by the Laplace transform of the unshifted function. The unshifted function is going to be t. So this one is going to be 1 factorial all over s raised to the power 1 plus 1, right? Plus 2 times, this one is the unit step function. The Laplace transform of the unit step function is going to be e to the negative as. A in this case is 1. So that is going to be 1s, which is s divided by s. So this is what we have. Now let's simplify our answer. So the Laplace transform of our function is equal to, this one is 0. E raised to the power 0 is 1. So we are left with 1 all over s squared. This is what we have. And now this one is going to be minus e raised to the power negative s. This is divided by s squared, right? And now plus 2e to the negative s all over s. So this is what we have for the Laplace transform of the fourth one. So we can rewrite it like this. So 1 over s squared, right? And then we can factorize e to the negative s out. So when you do that, you are going to be left with 2 over s minus 1 over s squared. This is 2 over s, beg your pardon. Alright, so this is what we have. We can put that in a box, and this one is going to be the Laplace transform of the fourth function. So now let's go to the fifth function. So the fifth function, this is what we have. So the fifth function, we are going to have this. So let me switch again. So for question 5, we are going to find the Laplace transform of this function. F of t is going to be something like this. It's going to be 0 for t less than 4. And it switches to the exponential function for t greater than or equal to 4. This is easy to graph. So it is easy to graph. We have this, our axis, our time axis, right? So as far as t is less than 4, as far as t is less than 4, like this, so let's say 4 is here. As far as t is less than 4, this function is 0, but it switches to exponential function at t greater than or equal to 4. So at t equal to 4, we are going to have e to the 2 times 4, which is e to the 8. So let's say e to the 8 is a positive number, which is somewhere here, e to the 8. So at 4, it is going to jump to this one, that is e to the 8, and then we are going to have an exponential function. And you know, an exponential function is going to behave like this going forward. So this one is the graphical illustration of what we have here. Cool stuff. Now, how do you write this in terms of the unit step function? So the unit step function, this is what we are going to have. So we are going to have f of t, and this is equal to so it is equal to 0. So now we have e to the 2t, and this one is going to be multiplied by u of t minus 4, like this. This is the unit step function. This function is the same as what we have here, right? So it is equal to this function, which is what you have here, for a value greater than or equal to 4. That is the unit step function. Now let's take the Laplace transform, shall we? So the Laplace transform of this function f of t, this is equal to the Laplace transform of this. So the Laplace transform of u t minus 4, this is multiplied by e to the positive 2t. Let me shift this one by 4 as well, why not? So we have the Laplace transform of, we have ut minus 4, right? And this one is going to be e2, so permit me to shift this one by 4, but I can't just do that. I have to add 4 to nullify the effect. And this one is going to be the Laplace transform of what? So these ones are the Laplace transform of f of t, Laplace transform of f of t. All right, so this one is going to be u t minus 4, and this one is going to be e raised to 2 t minus 4. This is multiplied by e to 2 times 4, which is 8. So that is using the laws of indices here. So e raised to the power 2 times the first one here, right? And then this is multiplied by e to the 2 times 4, which is 8. So now this one is a constant. The Laplace transform of the function f of t is going to be, this one is a constant in the t world. So this one is going to come out of the Laplace operator. And now we are going to have the Laplace of u t minus 4. This is multiplied by e to t minus 4, like this. And now let me refresh your memory again. So I will continue refreshing your memory until we finish this video. So we have the Laplace transform of ut minus a multiplied by f of t minus a. This one is equals to e to the negative sa times the Laplace transform of the unshifted function. So let's solve this one using what we have. The Laplace transform of f of t, this is equal to what really? So we are going to have e to the 8, right? And now this one is going to be what? So the Laplace transform of this one is going to be, we have e to the negative sa. So e to the negative, what is a in this case? A in this case is 4, right? So we have 4s. And now this is going to be multiplied by the Laplace transform of the unshifted function. The shifted function in this case is, so the shifted function here, so what is the shifted function? The shifted function here is equals to e to the 2 multiplied by t minus 4. But the unshifted function, right? The the unshifted function is equal to e to the 2t. So we are simply taking the Laplace transform of this unshifted function. And the Laplace transform of e to the 2t is going to be 1 all over s minus 2. Right, so the Laplace transform of our phi function, this one is going to be e to the negative 4s. This one is multiplied by e to the 8 here, and now this one is divided by s minus 2. Cool, so now we can combine this one as this. So the Laplace transform of f of t is going to be equal to e to the 8 minus 4s divided by s minus 2. And this one is the Laplace transform of our phi function. Cool, so now let's solve the last one. So the last one is question 6. So we are having the Laplace transform of this function. The function is giving us this. So this one is going to be e to the negative t, an exponential function for t in between 0 and 1. T in between 0 and 1, and now t if t is greater than or equal to 1. This one is easy to graph, so let me graph it for you here real quick. So like this. So this is our time axis. So for t in between 0 and 1, right? So in between 0 and 1, so we have in between 0 and 1. So let's say this is 0 and this is 1. So in between 0 and 1, you are going to have the exponential function. In between 0 and 1, the exponential function, you have the exponential function. That is what I'm saying. So the exponential function, in between 0 and 1, you have the exponential function. And the exponential function is going to behave in this way. So when t is equals to 0, we are going to have 1, right? So that is going to be 1 somewhere here. But when t is equals to 1, you are going to have something less than 1, because you have 1 over e, which is less than 1. So it's going to move until this particular point, right? So it's going to be something less than 1 here. All right, so but at 1, what happens? At 1, the function is now behaving like t. So what is t in this case? So when t is equals to 1, you can put it here, you have 1. So at t is equals to 1, the function is going to jump back to 1. That is from 1 here. Right, so at t is equals to 1, the function is going to jump back to 1, because at t is equals to 1, the function is t, and when t is equals to 1, the function is 1. All right, so it's going to jump to 1, and then when t is 2, it's going to be 2, and then it will continue from there. So it's going to be like this onward for t greater than or equal to 1. So this is 1 here. So this is what we have. This one is circle, but this one is field. All right, so this is the unit unit step function. This is the graphical illustration. So now how do you write this one in terms of the unit step function? This one is going to be what? It's going to be e to the negative t for values in between 0 and 1, right? So that is going to be u t minus 0, right? Minus u t minus 1, like this. And now plus t, and the value of the unit step function, that is u of t minus 1. So this is what we have. This one can also be expressed like this. So our function here can also be expressed like this. So now we can take the Laplace transform on both sides. But before we do that, let's simplify this one to match with what we already know. So we have f of t to be equal to what really? So f of t is going to be, this one is going to be e to the negative t multiplied by u of t minus 0, correct? Minus e to the negative t multiplied by u of t minus 1. All right, cool. And now this one is going to be plus t u of t minus 1. Now let's shift these ones. We are going to shift them. This one is t minus 0, so we don't need to do anything special here. So this one is going to be e. Let me just put this one as t minus 0. And nothing changes here, and then you have u of t minus 0. Cool stuff. But here this one is shifted by 1, so we are going to shift the exponent by 1. So e t minus 1, but we can't just subtract 1, we have to add 1 like this. Then you multiply by u t minus 1. And we are going to do the same thing for this t, right? So that is going to be t subtract 1 and add 1, right, to nullify the effect, multiply by u of t minus 1. Cool stuff. So f of t is going to be equal to, this one is going to be ut minus 0 multiplied by e to the negative t minus 0. Correct. And now minus, this one can be written as this, e negative, right, t minus 1. This is multiplied by e to the negative 1. That is using the laws of indices for this one. So this one is going to be e to the negative 1 multiplying by this. And now this one is going to be multiplied by u of t minus 1. And now next one, multiply the first two by this. That is going to be t minus 1 multiplied by u of t minus 1. And this one by this. That is going to be plus u of t minus 1. So you see, this one is a little bit complicated, and then we have this. So u of t minus 0 e to the negative t minus 0. All right, and now this one is a constant, e to the negative 1. That's 1 over e to the negative 1. And now we are going to have u of t minus 1. This is multiplied by e to the negative t minus 1. And now next one is going to be u of t minus 1 multiplied by t minus 1. And now plus u of t minus 1. Now our function is in what we are familiar with. So let me refresh your memory for the very last time. If you have the Laplace transform of something like this, so the Laplace transform of u of t minus a multiplied by f of t minus a, this one is equal to e to the negative sa times the Laplace transform of the unshifted function, and the Laplace transform of just the unit step function alone, this one is going to be e to the negative sa all over s. So now up until this point, that means that we can take the Laplace transform of the function, and when we do that, we have to take the Laplace transform of this function as well. So now let's split it. So the Laplace transform of f of t is going to be equal to what? So now compare this one. This one is going to be the Laplace transform of u t minus 0 multiplied by e to the negative t minus 0, like this. That's the first one. Minus this e to the negative 1 is a constant. We are going to have the Laplace transform of u t minus 1 multiplied by e to the negative t minus 1. We are done. And now plus this one, the Laplace transform of u t minus 1. This is multiplied by t minus 1, like this, plus the Laplace transform of u t minus 1. Cool stuff. Now let's apply these ones. So for the first one, we have this. A in this case is 0. A in this case is 0, right? So we have 0 here. So that is going to be e to the negative s times 0, right? Times the Laplace transform of the unshifted function. So the unshifted function in this case is what? The shifted function in this case is e to the negative t minus 0. The unshifted function is going to be, the shifted function is going to be e to the negative t. And how do you find the Laplace transform of e to the negative t? So Laplace transform of e to the negative t is going to be equal to what? So that is going to be equal to 1 all over s minus negative 1, like this. So we are done with this. We move to the second one. That is e to the negative 1 is a constant. Here, a in this case is 1, right? So we are going to compare to this one again. So that is going to be e to the negative s times a. A is 1, so that's going to be s on top, multiplied by the Laplace transform of the unshifted function. The Laplace transform of the unshifted function here is going to be e to the negative t, and that is going to be the same thing, 1 all over s minus negative 1. Cool stuff. So we just have to pretend the shift is not there, so we just take the Laplace transform of the function without the shift, right? So next is the third one. So this one is going to be equal to what? So here a here is equal to 1. That is what we have here. And now we are going to have e to the negative sa. So s times 1 is s multiplied by the Laplace transform of the unshifted function. The unshifted function here is just t. The shifted function is t minus 1. The unshifted function is t. So the Laplace transform of t raised to the power 1 is 1 factorial divided by s raised to the power 1 plus 1. Cool. And now the last one is the Laplace transform of the unit step function, which is this. So in that case, a is equals to 1. So that is going to be equal to e to the negative s times 1 is going to be s all over s. Alright, so this is the Laplace transform of the function f of t. The Laplace transform of the function f of t, this is going to be equal to e to the 0 is 1. So that is going to be 1 all over s plus 1, that is minus negative 1, minus e to the negative 1, right? And then we have times e to the negative s. This one is divided by s plus 1 as well, correct? Now next one is going to be plus e to the negative s. This is multiplied by 1 all over s raised to the power 1 plus 1 is 2 plus e to the negative s all over s. Cool stuff. So the Laplace transform of the function f of t, and this one is going to be equal to 1 over s plus 1 minus this one, using the laws of indices, this one is going to be e to the negative out. We have s plus 1. This is divided by s plus 1, right? Plus e to the negative s all over s squared plus e to the negative s all over s. And I think this one is the Laplace transform of what we are seeking to find. Alright, so we can just do some simple factorization and then we will be done with it. So the Laplace transform of this one is going to be 1 over s plus 1 minus e to the negative, right? E to the negative s plus 1 all over s plus 1 plus, we can factorize e to the negative s out, and now we are left with 1 over s squared plus 1 over s, like this. And this one is the Laplace transform of our last unit step function. Yeah, so that concludes this video. So these are the Laplace transforms of 6 6 unit step functions. So hopefully by going through all of this, you should be able to solve any Laplace transform of a unit step function. If you have any questions, feel free to put them in the comment section and I'll do my best to solve them. And if you really enjoy this video, consider subscribing to Calculus Diaries. Give me a thumbs up and follow all my tutorials on Laplace transforms. Like the video, comment down below and let me know what you think, and then I will continue uploading engaging tutorials on Laplace transforms. In my next video, I will continue to find the Laplace transforms of unit step functions. So you subscribe to my channel, like the video, and then I will see you in my next video. Bye bye.